Welcome to class. For our next topic, we're going to need to review power series. So how do we determine if series converge? Well, in your calculus class, you likely learned a few different methods. For power series in particular, though, the ratio test is a really powerful one to use, no pun intended. If you recall the ratio test, this works for more than just power series, but it's a good tool for power series in particular. If I look at the ratio of the next term over the previous term in a power series or in any series, and I look at the limit as k goes to infinity of that ratio in absolute value, I'm calling that limit L. If I get a number less than 1, I know the series converges. And if the number is greater than 1, well, the series must diverge. Do you notice this doesn't tell us anything if the limit happens to equal 1? So if L is equal to 1, the ratio test is just inconclusive. It means we don't get information either way. So let's use the ratio test on this example to figure out what values of x cause this power series to converge. Notice I've got a constant that may be defined by the index times some power of x. Well, let's look at this limit. So if I were to try and solve this problem, I would first need to look at this limit here. The limit as k goes to infinity of what I get when I plug in k plus 1, 2 to the k plus 1 over k plus 1 times 4x minus 8 to the k plus 1. And then I'm going to divide that whole thing by what I get when I plug in k. 2 to the k over k times 4x minus 8 to the k. And I'm putting absolute values around that whole thing. And there's a ton of stuff that cancels. In particular, I've got a 2 to the k and a 2 to the k that cancel, leaving me with 1, 2 on top. I have k copies of 4x minus 8 that cancel top and bottom, leaving me with 1 copy of 4x minus 8 on top. And so this whole thing immediately reduces to the limit as k goes to infinity of the absolute value of, I've got 2 over k plus 1 times 4x minus 8 all over k, but I'm just going to move that k into the numerator here. The 4x minus 8 pops out in absolute value, of course, because this is constant in k. I can pull it out of the limit as k goes to infinity, and what I'm left with is a quick L'Hopital's rule problem that gets me 2. Now remember, the ratio test tells me this is only going to converge whenever this quantity is less than 1. And it is common practice to solve this guy in the following way. I'm going to leave my x minus x naught term alone, but here I shouldn't have a coefficient on x. So I'm going to factor out this 4 from my absolute value, and of course absolute value of 4 is 4, and I get x minus 2 less than 1. So this tells me it converges whenever x minus 2 is less than 1/8. Little bit of vocab that goes with this. We call this whole piece, this would be from 2 minus an eighth, which is 15/8, to 2 plus an eighth, which is 17/8. Those are the values of x for which it converges. And this whole guy is called, hence, my interval of convergence. By the way, since we went out 1/8 from our center point in each direction, we call this sometimes the radius of convergence for the power series.